This lecture is about the basic measures for evaluation of text retrieval systems. In this lecture, we're going to discuss how we design basic measures to quantitatively compare two retrieval systems. This is a slide that you have seen earlier in the lecture, where we talked about the Cranfield evaluation methodology. We can have a text collection that consists of queries, documents, and relevance judgments. We can then run two systems on these data sets to quantitatively evaluate their performance. And we raised the question about which set of results is better. Is system A better or system B better? So let's now talk about how to actually quantify their performance. Suppose we have a total of 10 relevant documents in the collection for this query. Now, the relevance judgments shown on the right did not include all the 10, obviously. And we have only seen 3 relevant documents there. But we can imagine there are other relevant documents being judged for this query. So now, intuitively, we thought that system A is better because it did not have much noise. And in particular, we have seen that among the 3 results, 2 of them are relevant. But in system B, we have 5 results and only 3 of them are relevant. So intuitively, it looks like system A is more accurate. And this intuition can be captured by a measure called precision, where we simply compute to what extent all the retrieval results are relevant. If you have 100% precision, that would mean all the retrieval documents are relevant. So in this case, system A has a precision of 2 out of 3. System B has 3 over 5. And this shows that system A is better by precision. But we also talked about system B might be preferred by some other users who like to retrieve as many relevant documents as possible. So in that case, we'll have to compare the number of relevant documents they retrieve. And there is another measure called recall. This measures the completeness of coverage of relevant documents in your retrieved result. So we just assume that there are 10 relevant documents in the collection. And here we've got 2 of them in system A. So the recall is 2 out of 10. Whereas system B has got 3, so it's a 3 out of 10. Now we can see by recall, system B is better. And these 2 measures turn out to be the very basic measures for evaluating search engines. And they are very important because they are also widely used in many other task evaluation problems. For example, if you look at the applications of machine learning, you tend to see precision recall numbers being reported for all kinds of tasks. Okay, so now let's define these 2 measures more precisely. And these measures are to evaluate a set of retrieved documents. So that means we're considering that approximation of the set of relevant documents. We can distinguish 4 cases depending on the situation of a document. A document that can be retrieved or not retrieved, right? Because we're talking about a set of results. A document that can be also relevant or non-relevant, depending on whether the user thinks this is a useful document. So we can now have counts of documents in each of the 4 categories. We can have A to represent the number of documents that are retrieved and relevant. B for documents that are not retrieved but relevant, etc. Now with this table, then we can define precision as the ratio of the relevant retrieved documents A to the total number of retrieved documents. Right? So this is just A divided by the sum of A and C, by the sum of this column. Similar recall is defined by dividing A by the sum of A and B. So that's again, to divide A by the sum of the row instead of the column. Right? So we can see precision and recall is all focused on looking at the A. That's the number of retrieval relevant documents. But we're going to use different denominators. Okay, so what would be an ideal result? Well, you can easily see in the ideal case, we have precision and recall all to be 1.0. That means we have got 100% of all the relevant documents in our results, and all the results that we return are relevant. That means there's no single non-relevant document returned. In reality, however, high recall tends to be associated with low precision. And you can imagine why that's the case. As you go down the list to try to get as many relevant documents as possible, you tend to encounter a lot of non-relevant documents. So the precision would go down. Note that this set can also be defined by a cutoff in the ranked list. That's why, although these two measures are defined for a set of retrieval documents, they are actually very useful for evaluating a ranked list. They are the fundamental measures in text retrieval and many other tasks. We often are interested in the precision at 10 documents for web search. This means we look at how many documents among the top 10 results are actually relevant. Now, this is a very meaningful measure because it tells us how many relevant documents a user can expect to see on the first page of search results, where they typically show 10 results. So precision and recall are the basic measures, and we need to use them to further evaluate a search engine. But they are the building blocks, really. We just said that there tends to be a trade-off between precision and recall. So naturally, it would be interesting to combine them. And here's one measure that's often used, called F measure. And it's a harmonic mean of precision and recall. It's defined on this slide. Right? So you can see it first compute the inverse of R and P here, and then it would interpret the two by using a coefficients depending on a parameter beta. And after some transformation, you can easily see it would be of this form. And in any case, it's just a combination of precision and recall. Right? And beta is a parameter that's often set to 1. It can control the emphasis on precision or recall. When we set beta to 1, we end up having a special case of F measure, often called F1. This is a popular measure that's often used to combine precision and recall. And the formula looks very simple. It's just this, right here. Now it's easy to see that if you have a larger precision or larger recall, then F measure would be high. But what's interesting is that the trade-off between precision and recall is captured in an interesting way in F1. So in order to understand that, we can first look at the natural question. Why not just combining them using a simple arithmetic mean, as I have shown here? That would be likely the most natural way of combining them. So what do you think? If you want to think more, you can pause the video. So why is this not as good as F1? Or what's the problem with this? Now, if you think about the arithmetic mean, you can see this is the sum of multiple terms. In this case, it's a sum of precision and recall. In the case of a sum, the total value tends to be dominated by the large values. That means if you have a very high P or very high R, then you really don't care about whether the other value is low. So the whole sum would be high. Now this is not desirable because one can easily have a perfect recall. We can have a perfect recall easily. Can you imagine how? It's probably very easy to imagine that we simply retrieve all the documents in the collection. Then we have a perfect recall. And this will give us 0.5 as the average. But such results are clearly not very useful for users, even though the average using this formula would be relatively high. Now, in contrast, you can see F1 would reward a case where precision and recall are roughly similar. So it would penalize a case where you have extremely high value for one of them. So this means F1 encodes a different trade-off between them. Now this example shows actually a very important methodology here. When you try to solve a problem, you might naturally think of one solution. Let's say in this case, it's this arithmetic mean. But it's important not to settle on this solution. It's important to think whether you have other ways to combine them. And once you think about the multiple variants, it's important to analyze their difference and then think about which one makes more sense. In this case, if you think more carefully, you will feel that F1 probably makes more sense than the simple arithmetic mean. Although in other cases, there may be different results. But in this case, the arithmetic mean seems not reasonable. But if you don't pay attention to these subtle differences, you might just take an easy way to combine them and then go ahead with it. Until later, you will find that the measure doesn't seem to work well. Right? So this methodology is actually very important in general in solving problems. And try to think about the best solution. Try to understand the problem very well, and then know why you need this measure and why you need to combine precision and recall, and then use that to guide you in finding a good way to solve the problem. To summarize, we talked about precision, which addresses the question, are the retrieved results all relevant? We also talked about the recall, which addresses the question, have all the relevant documents been retrieved? These two are the two basic measures in text retrieval evaluation. They are useful for many other tasks as well. We talked about the F measure as a way to combine precision and recall. We also talked about the trade-off between precision and recall, and this turns out to depend on the user's search tasks, and we'll discuss this point more in a later lecture.